Okay, so we are discussing the question. So question was, so we got the questions by the using of the phasor, right? We need to discuss by the equation, right, Prasanna? By
Yeah,
phasor
other
five,
methods.
by phasor we did it.
Yeah.
And now we have to discuss with the equations, how to solve that equations with the equations. Okay, so see, the questions was what was the questions we have in the below given figure. So there was a, just wait for 2 minutes. So why it's not, just wait for 2 minutes. Yeah, so we have R1 and we have particular L. Okay, this was particular L. And here we have the V1 value and the current was I, and this is given as a positive negative V2, and this particular was VR, positive negative, this was positive negative VL, positive to negative VL. So this is your load. So how can we represent this equation? How can we represent these equations? Like if you want to write this particular equations, here V1 is given. Okay, if you want to write this particular equation, so how can you write this particular equation if you want to write? So V1 is equals to V1 will be equal to your V2 and VR. These all are in register now. So V2 plus VR will be in register, plus you have VL, that J VL. Okay, so if you want to calculate this, then what will be the results? V1 is equals to root under V2 plus VR square plus VL square.
Yes, good.
Okay, and this was your positive negative V3.
V3.
So V3 will be what? V3 will be root under VR square plus
VR square plus
VL square. VL square. Okay, now you have the value, of V1 value. You have V1 is given how much? 220 volt, and you have V2 value. V2 is how much? 122 volt, and you have V3 value. V3 is how much? 136 volt. Okay, now if you have this V3 value, you can solve now. V3 you can find the VL value now. V3 square minus VR square is equals to, this is VL, root under. Okay, you got the VL value. VL is equals to V3 square minus VR square under root. So VL value you are getting as what? VL is equals to root under V3 square minus VR square. Okay, fine. Now you need to substitute this value in place of this VL. What you will get? V1 is equals to root under, just solve this equations, V2 square plus VR square plus 2VL VR plus VL square will be V3 square minus VR square. So this VR square will get cancelled out. So what you are getting? V1 is equals to root under V2 square plus
V3 square plus
2VL VR plus V3 square. Okay. So if you are getting this, okay, now you know the value of all value you know. So how can you solve this? If you substitute the V1 value and you know the V2 value, see, V1 is 220, V2 is 122 and V3 is 136. So V1 we know, V2 we know, and we know V3 value. So from here we will get the value of a 2VL VR, right? Right? We'll get the value of a V1. Let me show you. Okay. Good. So this is V2, not VL. This particular is V2. Okay. V2 square to V2 VR. So substitute the value and get the results. V1 value is what? Can anyone tell me what is the value of a V1? 220 volt. So substitute 220 the whole square. You are getting what is the value of a V2? 122 square plus 2. What is the value of a V2? V2 is 122. And what is the value of a VR? We don't know. What is the value of a V3? V3 is 136 whole square. Solve this and get the result. 220 square minus 136 square divided by 2 into 122. You will get the value of a VR. So what you are getting? Just give me the answer. What? 220 square minus 136 square divided by 2 into 122. What is the answer of this? Prasanna, calculate it.
61.581.
61.581. So this was your VR answer. So we got the answer of our VR value. We got 61.581. Right. Here the resistance value is given, that is 5 ohm. So what will the current? Current will be how much current? 61.581 divided by 5. So what will the current? What is the value of this? 61.581 divided by 5 ohm. How much current will flow? Give me the answer for this.
12.316.
12.31. Okay. Now you know. Now you know the value of a current is 12.316. That too you have taken as a 0 degree. This is 12.316. 316 or 136?
316.
Okay, 12.316 at an angle 0 degree you took. So what I need to find the overall voltage across this. So overall voltage what you are getting means this load voltage V3 what you are getting, VR value we got it VR value was what? 61.581. Okay. What will the voltage of a VL? We know the V3 square is equals to VR square plus VL square. So can anyone tell me what will the value of a VL? V3 136 square minus VR value is 61.581 square under root. What will the value, Prasanna, tell me? 136 square minus 61.581 square. VL value. 136 square minus 61.581 square. What will the value? Hey, just wait for a minute. So what will the value? You just calculate it and tell me. Yeah. So guys, what I am telling, you have VL is equals to root under 136 square minus 61.581 square. So what value will come?
121.25.
121.25. So you got the load value. Load value means V3 value you got. That is 61.581 plus J 121.25. Can you convert this in the phasor form? What is the mod value of this V3 mod? Root under
root of
61.58. Just solve it na. 61.581 square plus 121.25 square angle tan inverse 121.25 divided by 61.581. So what is the value it's coming?
135.99.
135.99 at an angle in a degree. I want in a degree. Okay.
Yeah, 1 second.
At an angle 63. That's it. 63 only.
0.074.
0.074. You got the current. Current value was what? What was the current value? 12.316 at an angle.
12.316.
12.316 at an angle 0 degree. So if you will draw, means you have this particular load. This is your load. You got the load voltage as a 135.99 at an angle 63.074, and you have a current you got as a 12.316 at an angle 0 degree. If you draw this in the phasor, so I current is this, and your voltage is how much? Voltage is leading by 63. This is your V. Voltage is leading by 63.074. So the angle between voltage and current, load voltage and current, will give you the power factor. So cos 63.074 is how much? This will be your power factor. Solve it and get the result. Prasanna, what will the answer? Cos 63.45. 0.45. So by this way we can also solve. In the same way, we means like see, we did these questions in a phasor form. And we got the result. Yeah, we got the result 0.45, and VR value, that current value we got the same, Okay, so everything we got same only. So you understood how to solve this?
Yeah.
Everyone got it? So this was a very important question, and this can be solved by a two methods. So this was one of the method. And you need to calculate the power, means useful power. Always remember, useful power will always form across the register. So what I am telling, you know the value, you know the value of current. So what is the power? Power is I square into R. So useful power will be how much? Useful power will be I square upon R. So calculate it and get the result. I square into R. Just do it. I square into R. What was the current? 12.316. So square 12.316 and multiplied with R. You will get the useful power. Okay. You will get the useful power. So what will the useful power? Just calculate this. Prasanna, how much power you will get?
So 1 second.
Guys, solve it. So power will be how much? Useful power I square into R. So I value is 12.316, the whole square into 5. So this will be the useful power. So what is the answer you guys are getting? Guys, how much value you are getting? Vaishnavi, 12.316 square into 5, how much it will come? How much it will come, guys?
758.
758. So 758.41928 watt will come. This is your real power. If anyone will ask you about the reactive power, so load reactive power will be how much? If anyone is asking your load reactive power, then how much? Then you have to multiply it with, you have the voltage here and you have the current here. So just multiply V into this voltage into this current. Or you can do directly S is equals to V into I conjugate, overall voltage. So our overall voltage was how much? Overall voltage was 61.581 plus J 121.28. Okay, this was our overall voltage, 61.581 plus J 121.25. This was our overall voltage, and our current was how much? 12.316 at an angle 0 degree. Conjugate, I conjugate. So conjugate, 0 degree conjugate will be 0 only. Multiply this and get the result. You will get in the form of P plus JQ. So this P will be same. It will be same. So 61.581 into 12.316. How much value is coming? 60.
758.
Yeah, same value you will get. 61.581 into 12.316. So you are getting 758 only. Right, 758 plus J. And Q value will how much come? 121 into 12.
1493.
12.316. So you will get 1493, right?
Yeah.
1493. Okay, 315. So this is what? This is your QL, reactive power of the load, and this is the real power of the load, useful power, what we are calling.
So without taking this S equal to V into I conjugate, how we can do the other method
Means
to get the reactive power?
what are you telling?
Without using this S equal to V into I conjugate,
See,
how we
if
can
you
do
if you want to calculate like this without using S is equals to V into I conjugate, so like what you did for what you did here, what you did here. Here we have a register, right? So R square into I we did. Okay. Here if you have the value of XL, then you can do XL square into I. Okay. Otherwise you can find the value of XL. XL can be found how you can find the value of XL. You know the value of a V, particularly in this branch, V divided by I will give you the XL value. If you know the XL value, so square it with your current, you will get the same result. Got it?
Yeah.
And you can do one thing also, like you know the value of a potential, you know the value of a value. Here value is directly, you know the value, that is
DC
121
value.
121 value, and you just multiplied with 12.316. So you will get the Q across this.
Yeah.
That's it. Got it?
Yeah.
So these things, by this way we can solve these questions, right? Everyone, this part is clear? So almost we completed our AC circuit. Vaishnavi, for you it's clear. Sharon, for you it's clear. Or you guys are facing any doubt, you can ask.
So we generally say power loss formula is P equal to I square into R.
Your voice is not coming properly. Yeah, what you are saying?
Power loss formula is P equal to I square into R, right?
Yeah, power loss formula is P is equals to I square into R.
But here we are calculating useful power at R is P equal to I square.
Whatever, why I am calling a useful power. See, what I am telling, why I am calling this as a useful power, because this is our appliance, like a heater. So this heater is consuming some power. Okay, so that's why I am calling it as a useful power. Okay. Other, although it's a power loss only, but this power loss, suppose this was a heater which having a resistor and an inductor, so the amount of resistor, the resistor will give the useful things like a heat and all. And these inductor, whatever the inductor consuming the power now, this power will come in a wire and all for transforming purpose, for generating the things. So that's why this is known as a reactive power. Okay. Useful power means the things what we are actually using, but the reactive power is,
According to application.
yeah, reactive power is like a transforming, means the power wasted in the transformation form. Okay. Okay, just wait. My tab is not, just wait for a minute. just wait, I have to install the driver. So you are getting, means what I am telling, the power which are you, which generally use for a transformations and all the things like inductor, capacitor, these things these things is known as what, it's known as a reactive power. We'll see these things in a power system and electrical machines. Okay. So
With respect to the resistor, we called as real power, and with respect to the inductor and
inductor
capacitor,
and
we called as
capacitor we
reactive
call
power,
as a
right?
reactive power. Okay. But
Yeah.
the thing is that now there is a many more concept regarding VAR, KVAR. Okay, you will get to know very soon. So just have some
Okay.
patience. Have some patience. I will tell you. So so have you solved, means like the previous questions you have solved, the basics network questions you guys solved. Are you solving or not solving? Just tell me. You guys are solving those questions or not? Yes, Anna, have you solved that questions?
Up to the questions which we have solved in the
Yeah,
class,
up to questions we have 50 we
done.
have to solve. But have you tried by yourself?
Yeah, I've tried by myself up to the questions what was told in the class.
So up to that part only you had solved.
Yeah.
No, you have to try. Means you have to try more na. If you will do like this, then oh, how it will happen? Okay, you have to try by yourself also. Okay, just wait here. This driver, means I am facing problem with this tablet digital pad. It's not getting synchronized. Oh, what's happening? Just wait for a few minutes. Or you tried that questions, means after 15 you had tried now. You guys just do the 16 number question. Let me fix this issue. Okay. 50 means 16, 17, 18, we'll discuss it. Okay, so just try that 16, 17, 18 questions right now. It's removed. It's working. So have you tried? Means which questions you are trying, Prasanna?
16.
16 questions. So have you solved it? Are you able to solve it? That 15 questions?
Sir, I got answer.
16 questions. 15 you are trying, na? 15 or 16? Hello.
60. Oh, sorry. It's a bit big.
15 you didn't write. Okay.
After I've completed.
Okay, let me solve the 15 questions. See, first we'll do the 15 question. So in a 15 questions, we have a 2 ampere. Okay. And this particular positive negative 10 volt. And this is 1 ohm. This particular is a 4 ohm. This is positive negative 4 V naught. Okay, so in this question you need to find the total power delivered by the dependent source. So what is the dependent source? What is the dependent source? This particular is the dependent source. So total power delivered means you have to assume the current deliver. So current entering to the negative terminals, then only it will call as deliver. So you have to assume the current in this particular directions. Okay, so suppose the I1 current is flowing in this and you have a 2 ampere current, you are assuming X. Okay, so and V naught will also be given. This particular is your V0 and this is 1 ohm. So how you will solve this question? So see, apply the nodal analysis. You have this branch current, you have this branch current. So net incoming current is I1 incoming current, And what is the net outgoing current? Net outgoing current will be 2 ampere, right? This will be the net outgoing current. Okay, what will be the net outgoing current? This particular will be the net outgoing current, and if you will take the KVL in this, so I1 will be equal to 2 ampere plus x minus 10 divided by 1, x minus 10 divided by 1. So you are getting the value of I1. Okay, you are getting the value of I1. Okay, and if you are getting the value of I1, you can do one thing also. You can do one thing also, like you got the value of I1, that is I1 is equals to 2 ampere plus x minus 10. So what will the value of x? I1 plus 10. So I1 plus 10 minus 2 is equals to x. So x will be I1 plus 8, right? X will be I1 plus 8. So if you know the value of x, what will be the current in this particular branch? In this particular branch, I1 plus 8 minus 10, I1 plus 8 minus 10 divided by 1. This will be the current in this particular branch, and if you multiply this with 1, you will get the value of a V0. So V0 value you are getting how much? I1 minus 2. I1 minus 2. And you know the value of I1. You know the value of I1. That can also be solved like this: x minus 4 V0 divided by 4 is equals to minus I1. So x minus 4 V0 is equals to minus 4 I1. So now put the value of x. X was I1 plus 8 minus, put the value of a V0, I1 minus 2 minus 4 I1. Get the results of I1. I1 plus 8 minus 4 I1 plus 8 minus 4 I1. Solve this. You are getting I1 value is minus 16. I1 value you got as minus 16. If you know the value of I1, what will the value of a V0? Minus 16 minus 2, that is minus 18. Now you know the value of a V0. What will be the value of a 4 V0? 4 into minus 18. So 4 into 18 is how much? Minus 72. Minus 72. So power will be how much? Minus 72 into minus 16. So minus 72 into minus 16. This will be 1152.
1152.
So power is coming as 1152. So which option will be the correct? Option A. Understood or not? Or you need to repeat this again? I know you didn't understood. See what we have. We have a resistor. In this particular, it's given as a V0. This as a 1 ohm. This particular is positive negative 10 volt. This branch current is given as a 2 ampere, and particular resistance, that is 4 ohm, that is positive negative 4 V0. Okay, this is 1 ohm. So what I am assuming? I am assuming X, and I am assuming, because it is a delivered power, so you have to assume the current in this way, I1, because I told you already, the delivered power will cross the negative sign, will enter into the negative sign. Okay, so this is the dependent source. So they ask the power across the dependent source only. So apply the KVL. So if you will apply the KVL, see, if you will apply the KVL, what is the equations? What are the equations you are getting? So incoming currents and outgoing current concept. So incoming current is I1, outgoing current is 2 ampere, and you are taking one current in this way, so this will be outgoing current. So outgoing current will be x, this particular node, minus this voltage, x minus 10 divided by 1. So what equations you are getting? I1 value you are getting x minus 8. So what will the value of x? X will be I1 plus 8. You got the node value. Okay. So if you want to find the current, means like I1 current you got x minus 8, and this same currents you can apply the KCL. You will get the value of a current in this branch itself. So you apply and get the results. Means suppose this branch, in this branch current is y. Okay, so 2 ampere will be equal to this is outgoing current. This particular is outgoing current. So 2 ampere plus y will be your I1, right? So y will be I1 minus 2. So I1 minus 2, I1 value is x minus 8. So x minus 8 minus 2, what value you are getting? X minus 10. Am I correct? Prasanna, you are getting the things or not? Just say me. See, this particular what I am doing you are not getting, right? This is your junction. So if this junction I1 current is entering, and if 2 ampere current is leaving, what will be the particular current? If you want to find the current in this branch, so you can directly do also like this, x minus 10 divided by 1. So this will be the current, this y value, and we can do like this also. So you know the value of a y current that is flowing. What will the value of a V0? V0 will be, V0 is nothing but y into 1. So V0 value you are getting x minus 10. Okay, now you had assumed the I1 current like this, and if you do the nodal analysis, the equivalent of a I1 will be what? Equivalent of a I1 will be minus I1. If you will assume the current in this particular direction, so it will be minus I1. So x minus 4 V0 divided by 4 will give you minus I1, and x minus 4 V0 minus 4 I1. So the value of x you got as a I1 plus 8. So I1 plus 8 minus 4, and V0 value you got as a x minus 10. X minus 10 into minus 4 I1. If you solve this, you will get the value of I1, that is I1 plus 8 minus 4x plus 40 minus 4 I1. Substitute the value of x is I1 plus 8 only, and V0 value is substitute the value of x value. If you will substitute, that is I1 plus 8 only, or substitute here itself. Don't make it use, like if you will substitute I1 plus 8 minus 4 into I1 plus 8 minus 10 into minus 4 I1. So what it will come? I1 plus 8 minus 4 I1, it will become minus 2, so it will become plus 8, and minus 4 I1. So these minus these getting cancelled out. So I1 value you are getting minus 16. Now you need to find the value of a V0. If you need to find the value of a V0, and you have the if you need to find the value of a V0, you should know the value of x. You have I1 value, so substitute here. You will get the value of x. So x is I1 plus 8, that is minus 16 plus 8, and you are getting minus 8. Substitute here V0 value. So minus 8 plus minus 10, you are getting minus 18. So minus 18 you got. So here overall voltage is 4 V0. 4 V0 means 4 into minus 18. So you are getting minus 72. So power will be what? This V into I. So V total voltage is minus 72 and total current is minus 16. So you are getting 1152. Have you got it? Or again I have to understand. Means anything, any issues you are facing, Prasanna, Vaishnavi,
I understand.
understood? Everyone? See this. That's why I'm telling to you guys. You need to practice more and more. If you will only read the concept, na, so the things will not happen. If you want to clear this exam, you need to practice the question. The more questions you will practice, the more understanding you will develop. Okay. So and so this answer is option A. And question number 16 you guys were solving. So question number 16, try to see. You have a question like 5 ohm. This is 5 ohm. This positive, negative, positive, negative. It's battery it's given. So V1 value is 20 volt. Okay. So the dependent current source in the figure. So dependent current source is what? V1 by 5 ampere. This is your dependent current source. So here also they had asked what? They had asked the power. Means how much power, either the power they absorb or deliver. Okay. So they are asking about the power. So assume what I am telling, you assume the directions like this: positive, negative. Means your negative current is entering in this, so you are assuming as a power delivered you are assuming. If the power is coming negative to this, it will become absorb. So, and what is the V1 value is given? V1 value, it is given as a 20 volt. Okay, you need to find the voltage across this. How you will find? Take it as a x. So, and what is the current? So current will become how much? Because V1 value directly they had given. So it will be 20 by 5. Means 4 ampere current is flowing in this. 4 ampere current is flowing in this. So what you will get? And means if you will apply the nodal analysis, you are assuming I1 here, you are assuming I2 here. So what will the nodal analysis? 4 ampere is equals to I1 plus I2, and this is your reference. So for I1 will be x by 5 and I2 will be, I1 will be x minus 20, x minus 20 by 5, x minus 20 divided by 5, and I2 will be x by 5. So 4 x by 5. So what you will get? 2x minus 20 into 5. So you are getting x value is 40 by 2. You are getting x value is 20. So this is your 20. So that means if this potential is 20 from here to here, it is 20. Positive, negative, 20. So this means the potential across this is 20 volt, and the current it's delivering as a 4 ampere. So what is the power it's coming? Power is coming, entering in this. So power is 20 into 4, that is 80. So it is coming positive only. So we assumed in this direction only. So power will deliver only. So how much power it will deliver? 20 into 4, 80 watt. So it will, because the current is coming into the negative direction. If the power was coming like this, minus 80, and the option there will be a no negative sign, then we have to say power absorbing. Okay, but here according to our assumptions, it's coming 80 watt only. So power will absorb 80 watt. Is this clear to everyone, or still having any doubt? Prasanna, is this clear?
So directly we can say P equal to V into A, right? I is in the independent source current value is 4.
Okay.
And we know the voltage value is 20, so 4 into 20 is 80.
4 into 20 is 80, but See,
You don't know it is
yeah,
delivered
yeah,
or absorbed. That's
you
it.
are assuming the potential like this, positive, negative, okay, this side, and you are having a current is entering like this. You had assumed the current, so it entering to the negative terminal means you are considering power delivering concept. Okay, you are assuming
Yes.
what power delivering concept, and if the value is coming positive, then means that means your assumption is correct. If the
Correct.
if the value was opposite to this, like minus 80, then it means power
Power absorbed.
absorb. Okay, got it.
Yeah.
Okay, so let's go to back to the topic. So please try to solve it, yeah. Okay, means if you do by yourself, solve wrongly means I'm not saying that you have to solve correctly all the answer. I'm saying just try and get any wrong answer. If you'll do the if you'll do incorrect also, then you will correct na. So how you will know it, whether I am doing correct or wrong? You have to solve the questions again and again, and it will make a interest, it will develop a interest. So you guys develop an interest by solving these questions, then you will enjoy this subject. Okay, if you will not solve the questions, then it will become a boring, right? So try more and more questions, and I said you that purchase the get questions bank. So have you ordered it? So see, you guys are not
Yeah, we did.
you did, then it's fine. because because if you will not practice the previous year questions bank and you are going directly to the get examination, then how you are expecting that you will qualify this exam? You need to practice more and more. Okay, so okay, sinusoidal is done. There is a 2 3 concept, right? Root mean squares and all, we'll study that. Before that, yeah, we discussed these things. Okay, so write one question. Find the value of a capacitance. Find the value of a capacitance. Find the value of a capacitance C when the power factor of the circuit is 0.8 lagging. So power factor of the circuit is given, and you have a circuit, you have a circuit you have a circuit like this. This is your circuit. This particular is 1 ohm, this particular is 1 Henry, this is your capacitor. Okay, and you have sine t, that meaning omega value is given as a 1. Okay, so this is your y1 branch and this is your y2 branch. So guys, if you need to solve this question and it is given as a 0.8 lagging, 0.8 lagging means what will be the means cos phi value is given as 0.8. So what will be the inverse of cos phi? Guys, what will the inverse of a cos phi? Cos inverse 0.8.
Thirty-six point
36.86. So phi angle is given 36.86. If it is given lagging means you have to consume minus 36.86. Okay, and in a questions, lagging and leading means, if they are directly giving lagging, leading, then you have to consider your current is lagging. Okay, your current is lagging. So current is lagging means your voltage is leading. This particular is your voltage and this is your current. Leading, lagging by how much angle? 36.86. Okay, so this means what? Your current is lagging, it's behind, and your voltage is leading. Okay, so you need to find the relations between this. And what is the value of this 1 sin omega t? 1 sin omega t can be written as how much value? 1 upon, that is, we have to see Vm sin omega t. So what is the value of a Vm? It's 1. Omega value is 1. Then in the phasor form you have to write like this: 1 upon root 2 at an angle 0 degree. This is your V phasor. It is given. Why 1 by root 2? Because we write directly VRMS. That's why we divided it by 1 by root 2. So it's coming 1 by root 2. Now what will be this Z? Z of this? R plus J omega L. So what value you are getting? 1 plus J, omega value is 1. Omega value, see, sin omega t. So omega is 1 and L is 1. So 1 plus J is coming. And this is Y2. Y2 is here means Z2. If you write Z2 is R plus R minus J by omega C. Omega C will come. And this is given as a 0. So Z2 is how much? Minus J upon C. Omega value is 1. Okay. So what will the value of a Y? This Y parameter will be 1 by Z. So 1 plus J. And what will be the Y2 value? Y2 value will be C upon minus J. So Cj will come. Cj will come. So overall Y will be Y1 plus Y2. So you are getting 1 divided by 1 plus J plus Cj. If you will rationalize this, what you will get? 1 minus J divided by 1 plus 1 plus Cj. So this overall Y you are getting. So make the real term one side and imaginary part one side. So 1 by 2 plus J you are taking common, C minus 1 by 2. C minus 1 by 2. Okay. So this is C minus 1 by 2. It's coming. Okay. So you are getting the Y value this particular. What is the relation between V and V? V is equals to I into Z. So what is the relation between? You can write I is equals to V into Y. Okay. I is equals to V into Y. So you know the value of a V, 1 upon root 2 at an angle 0 degree, and you know the value of Y, 1 by 2 plus J C minus 1 by 2. And I told you this is your, if you solve these equations, I will come how much? 1 by 2 root 2. This is 0 degree, so it's not needed, divided by J by root 2 into C minus 1 by 2. You are getting something like this. Okay. Now see what I told you. This is a lagging load. Okay. Because your current will lag. According to the questions, current will lag. So lagging means what? This value should be negative. So that means what? C is lesser than 1 by 2. That's why the minus will come negative. Okay, so you can do like this, 1 by 2 root 2, take minus sign outside, minus j by root 2, 1 by 2 minus c, means I just taken the minus sign outside. So we are getting the angle like this, and V angle we have taken 0 degree. Okay, and I angle we are taking, I is lagging, I is behind, so I angle will be minus 36.86. So solve this, tan inverse b by a, tan inverse b by a, so minus 1 by root 2 into 1 by 2 minus c divided by 1 upon 2 root 2. So you will get minus 36.86. So it will come, this 2 will go upside, so it will be minus 2 1 by 2 minus c, and this tan minus 36.86. So what is the value of a tan 36.86? Tan 36. Prasanna, what is the value of a tan 36.86?
0.749.
0.749. Minus 36.86. Minus, put the value of a minus. Tan minus 36.86.
Minus 0.749.
Minus 0.749. And this is minus 2 into 1 by 2 minus c. Solve this equation. This minus will cancel out. 1 by 2. And if you solve this, what you will get? So 2, that is 1, minus 2c, it's 0.749. 1 minus 0.749 divided by 2 will be the value of a c. So 1 minus 0.749 divided by 2. So how much value you are getting? C value is 0.1255 farad. This is your answer. Or you can do like this also. If you remember the previous formula, cos theta in a parallel circuit, cos theta was g upon y. So with the help of this also you can solve this question. Okay, so g will be what? G will be this will be g, and y will be what? So g will be, you have to put 1 by 2 divided by root under, y will be 1 by 2 ka whole square plus c minus 1 by 2 the whole square, c minus 1 by 2 the whole square, and cos theta value you have to put 0.8. So you can solve like this also, you will get the same result. Okay, see how I solve this question. I will again tell you. Here it is written, find the value of a capacitance. Okay, when the power factor of the circuit is 0.8 lagging. Lagging means cos phi is 0.8, you are getting the value of whatever the angle. Lagging means minus 36.86. And this lagging means generally nothing is representing, means lagging means your current is lagging by some angle. Okay, so current is lagging by some angle, so current is behind 36.86. So current is behind 36.86 means you have a current at an angle minus 36.86. It's given. If you will take the reference, you have to draw minus 36.86 like this, 36.86, and your voltage is at an angle 0 degree, so that's why it is in this point only, V. So these and these figures are same. Okay, so you know that I at an angle minus 36.86. Okay, so what I did, this c can be written as minus j upon omega c, and the omega value was 1. Okay, so minus j by c. This is your z in z term. If you will write in the y term, then it will become c upon minus j. It will give you cj only. Okay, and this will be how much? 1 plus j, because j omega l, omega value is 1, so 1 plus j. And what will be the y? 1 divided by 1 plus j. And overall y is overall y is what? Overall y is y1 plus y2. So we are getting 1 plus j plus cj. Now rationalized. What I did, I rationalized this. 1 divided by 1 plus j plus cj. I rationalized it. 1 minus j divided by 1 plus j. So if you will rationalize, you will get 1 square minus j square. So minus j square will become 1. So 1 minus j by 2. If you will if you will if you will do the real part and imaginary part sides, so you will get 1 by 2 plus j into c minus 1 by 2. You got the value of y. Now what I am telling, v is equals to I into z. I is equals to v by z. So I is equals to vy. Vy. What I am telling, I is equals to vy. And here it is given in the question it's given I at an angle minus 36.86. Okay, and v it's given 1 by root 2 at an angle 0 degree. And you have the value of a y, that is 1 by 2 plus j c minus 1 by 2. Okay, you have that value. So if you will convert this in the polar form, what you will get? 1 by root 2 at an angle 0 into if you will convert this into the polar form, you will get this will come root under 1 by 2 the whole square plus c minus 1 by 2 the whole square at an angle this will have an angle tan inverse this c minus 1 by 2 divided by 1 by 2. So you have this angle. So and now you are adding this angle, so you are getting minus 36.86 is equals to tan inverse c minus 1 by 2 divided by 1 by 2. Okay, now what I am telling, you need to take this tan this side. So if you will take tan 36.86, that is minus 36.86, and c minus 1 by 2 divided by 1 by 2. So 36.86 into tan, just wait. So tan, you are getting 36.86 into pi into 180 inverse, you are getting minus 0.749 into 1 by 2 to c minus 1 by 2. So plus 1 divided by 2. So you are getting the value of a c as 0.125. 0.125 means what? 1 upon 8. This part is clear, Prasanna, how we solve this? Is this guys clear?
It's clear.
Okay. So this was a very important question and very important concept. So I'd explained these things to you guys. So now if it is clear, then we are going to the next topic, RMS. Write the next heading, RMS. RMS. What is root mean square? What is RMS? Can anyone tell me what is the true meaning of a RMS? What is the true meaning of RMS? Prasanna, Vaishnavi, Priyanka, what is
No
RMS?
idea.
Vaishnavi, you know what is RMS? Priyanka, you know? Guna? Okay. See, the true meaning of a RMS is what? The full form of a RMS, so it's root mean square. Okay, value. See, RMS value is defined based on the heating effect of the waveform. It is giving the means in a AC it will give you the equivalent DC form. Equivalent DC form. RMS is nothing but equivalent DC form. Okay. So RMS definition, write it down. RMS value is defined based on the heating effect. RMS value is defined based on the heating effects heating effect of the waveform. Okay, so what is the true meaning of RMS? The voltage at which the heat dissipated in AC circuit so this is a very important question. The voltage at which the heat dissipated in AC circuit is equal to the heat dissipated in the voltage at which the heat dissipated in AC circuit is equal to the heat dissipated in DC circuit. So at what voltage some heat will dissipated in AC circuit will be equal to the heat dissipated in the DC circuit. That is nothing but it's a RMS value. Okay, so it's called the RMS value. So what I am telling, you are taking Vm, means in a sinusoidal you are taking VR by root 2. So Vm was 50 sine omega t. If you have connected a resistor with an AC circuit and the value is 50 sine omega t. So what is the RMS value of a 50 sine omega t? 50 by root 2. And this resistor was what? This resistor was 5 ohm. 5 ohm resistor. So what kind of a heat will dissipated? 50 by root 2 square, V square by R. So this is the power. And if you will apply the same 50 by root 2 means a DC in a DC, this 50 by root 2 is equivalent to your DC value. Okay, so means 50 sine omega t. If you want to represent this 50 sine omega t in a DC form, you have to take 50 upon root 2. That's what it is saying. The voltage at which the heat dissipated in AC circuit is equal to the heat dissipated in the DC circuit is called RMS value. Okay. Okay. See, provided both AC and DC circuit have a equal value of resistance. Provided both AC and DC circuit have equal value of resistance and are operated in same time interval and are operated in same time interval. So this is your RMS value. Means what? Like in the circuit form, write it down. You have R, you have VAC at time t. Now if you want to represent it in the DC form, you have R. This is your positive negative VDC at t. So WAC is equals to WDC. Means energy at AC signal will be energy at the DC signal. Okay. So how we calculate the RMS value? Means energy, means whatever the energy at this particular time you are generating in this resistor, what kind of a voltage is needed to generate this particular heat. So this will be equal to at what DC voltage you are getting. Means suppose you at some AC voltage you are getting 50 watt. So in a DC signal at what DC voltage you are getting the same power, that DC power is nothing but your RMS power of this particular voltage. So how we find the RMS value? So Vrms is nothing but root mean square upon 1 by t overall time period 0 to t into square. Root mean square means you are taking a mean average value, square of the average value. So you are taking the square of the signal into dt. So this is the formula. This particular is the formula of your.
So what about that VRM is equal to VM by root 5? Sorry, root 2.
Vm by root 2. We'll calculate now. How that was coming, I will show you.
Okay.
So this is your RMS value. Vrms is nothing but root under 1 by t 0 to t v square of t into dt. Now what I am saying now, if you will put the value sine omega t in this equation, you will get the Vrms as Vm by root 2. Okay, so how it's coming I will show you. So we have a sinusoidal wave. Suppose we have a sinusoidal wave. We have a time period of 2 pi. So we can write like this also. Vrms is equals to root under 1 by total time period is 2 pi. Integrations of 0 to total time period is 2 pi v square of t into dt. Okay. Up to this it is clear.
Yeah.
Everyone, it's clear. Vaishnavi, for you it's clear?
Yes, sir, clear.
Okay. So remember this formula. It's very important. Vrms is nothing but means it's market very important. This formula. Vrms or this formula. Vrms is 1 by root under 1 by 2 0 to 2 0 to t v square of t into dt. Now I will ask you, what is the average value? What is average value? So if anyone asks you what is the RMS, actual meaning of RMS, what you have to say? The full form of our RMS is root mean square. And what is the definition of a RMS value is? It is defined as a based on the heating effect. First of all, you have to tell this line. It's a very important. RMS value is defined based on the heating effect. Okay, and voltage, and what is the actual meaning? The voltage at which the heat dissipated in the AC circuit is equal to the heat dissipated in the DC circuit is called the RMS value, provided both AC and DC circuit have equal value of resistance and are operated in the same time of interval. So mug up these definitions. It's very very important. Means
Can you show the previous slide once again?
Right. Yeah. Yeah, this is RMS value is root mean square value. RMS value defined based on the heating effect of the waveform. The voltage at which the heat dissipated in AC circuit is equal to the heat dissipated in a DC circuit is is called the RMS value, provided both AC and DC circuit have equal value of resistance and are operated in the same time interval. It's very important definitions in a core company. In any core company, they will ask you this, what is the actual meaning of RMS. So everyone will say that is root mean square, but they will ask you what is the meaning of that root mean square. Then you have to say this particular paragraph. Got it? Means you are applying the AC value, AC voltage, particular AC voltage, and whatever the energy you are getting across, heat energy, whatever you are getting across particular at particular some particular time, means like a 2 second, 3 second. So whatever, means suppose you are getting the heat loss as a 50 watt. So in that, in if you will apply the DC voltage, at what DC voltage you will get the same result, then this DC voltage is your RMS value of this AC voltage. Okay, Prasanna, it's clear?
Yeah.
Okay, so now we are going for the average value. So in the same way, what is the average value? So write out the definitions of the average value. Average value is nothing but the average value is defined based on the charge transforming the circuit, charge transferring the circuit, charge transferring in the circuits. Okay, so voltage at which charge transfer an AC circuit is equals to the charge transfer in the DC circuit. So the voltage at which charge transfer in AC circuit is equal to the charge transfer in the DC circuit. This particular is your, so it means what, at equivalent charge transfer. So the voltage at which the charge transfer in AC circuit is equal to the charge transfer in a DC circuit is called as your average value. And here also the both AC and DC circuit have an equal value of resistance. So here also both AC and DC circuit having a equal value of resistance and are operated for same interval of time, and are operated for same interval of time. Okay, so for remember one thing, average value will always 0. For unsymmetrical network it won't be a 0, but for a symmetrical network will always be a 0. Unsymmetrical, V average is nothing but it's a mean 1 by t, 0 to t, V of t into dt. And for symmetrical V average will be 0 full cycle. V average will always be 0. Okay, for full cycle. How so? I will show you. Symmetrical towards means x-axis. Yeah.
So can you read that sentence once again? Both AC and
See,
DC circuit having an equal value.
the average value is defined based on the charge transforming in the circuit. Okay, the average value is defined based on the charge transferring.
Yeah, that is okay. The last third sentence I want to say.
This third sentence,
Yeah.
both AC and DC circuit having a equal value of resistance. Both AC and DC circuit having a equal value of resistance and are operating for same interval of time. Okay.
Yeah. Okay.
So these things are in notes only, so you can go through that notes, you will get these things. Okay. But better you write now, it will be more useful. Okay, so means like a symmetrical network, see, so unsymmetrical network V average is equals to 1 by t, 0 to t, V of t into dt. For symmetrical network you will get V average is equals to 0 0 for full cycle. How so? Suppose you have a sinusoidal wave. So what is the sinusoidal wave? It's continuing like this. So positive, negative, positive, negative. So this is one cycle. So this part and this part will make you 0. That's why for symmetrical network it will be same upside and downside, or like we can say symmetrical network not upside downside. From y-axis you are getting the same thing. This mirror image is coming. So this kind of a network is called a symmetrical network, and you are getting your average value as a 0. Okay. And here also means you are getting this positive is coming downside and this negative is coming downside, so it should become like this also. So that's why means like the average value will be 0 here. Okay. So like you have a circuit like this, you have a waveform like this. So what is the meaning? Positive, negative, positive, negative. So it will give you overall result is 0. If you have a triangular pulse like this, so positive, negative, it will give you 0. Okay. This part is clear, guys? See, for a symmetrical network, what is happening now? This is A1, this is A2. So mod of A1 is equals to mod of A2. That why this result and this result is getting cancelled out. But for unsymmetrical network, it will be like this. If some value like this, some value like this, some is like this, some is like this. Okay, so it's having some positive, a small amount of positive thing, but it's having a huge amount. So if you will sum this part also now, you will have some negative value, so it won't be a 0. Okay, so suppose you have a particular signal. This is consuming area 1 and this is consuming area 2. So average value means your area 1 value A1 is equals to A2. That's why this and this will minus and it will give you 0 result. Okay, but this is applicable in symmetrical network. But for asymmetrical network, this A1 will never be equal to A2. Okay. Now guys, just now I told you the formula. Suppose how we are getting Vm is equals to, means the RMS value is equals to Vm by root 2. See, you have a sinusoidal graph, that is T, that is V of T, and this is your sinusoidal graph. So I am solving for one, rest you can do by yourself. Apply the same thing, same formula, and get the result. So here we have a V of T is equals to Vm sine omega t. Okay, 0 to time period is capital T, I am assuming. Okay, 0 to capital T. So what is the formula for RMS? 0 to capital T. So VRMS formula is what? Root under 1 upon T, 0 to T, V square of T to dt. So what is V of T? If you will substitute VRMS, root under 1 upon T, 0 to T, V square means Vm square sine square omega t into dt. So what is the formula for sine square omega t will come? Cos 2 theta is equals to how much? Cos square theta minus sine square theta. So sine square theta will be, or cos 2 theta is equals to 1 minus 2 sine square theta. So sine square theta will be how much? 1 minus cos 2 theta divided by 2. So put this in the form of this, 1 upon T, 0 to T, Vm square into 1 minus cos 2 omega t divided by 2 into dt. Okay guys, now this is the constant parameter, so if you have to take it is on the outside only, Vm. This is 1 by T, this is 0 to T. What is the integrations of this 1 by 2? 1 by 2, we are getting like this, 1 by 2 minus 0 to T cos 2 omega 2 by 2 into dt. So what is the average? This is your what? This is your average value, 0 to T. So it will be 0 only. Average value of any trigonometric function will be 0. Solve it and get the result. You will get the 0 only. Okay. Okay. So now you have this parameter, Vm 1 by T, this is 1 by 2 into T minus 0. So this T will get cancelled out. So you are getting Vm by root 2. How this is coming? Average value is 0. I will show you. 0 to T cos 2 omega t by 2 into dt. What is the integration of a cos omega t? Sine 2 omega.
Fine.
Yeah. So you are getting sine 2 omega t divided by this 2 will get, this 2 omega will come downside.
4.
So 2 omega into 2, and the result is from 0 to T. Okay. Now put the value sine 2 omega t by 4 omega minus this 0 is 0 only. So omega is 2 pi f. 2 pi f. So this can be written as 2 pi f is 1 by t only. So sine 2 into 2 pi into 1 by t into t. This getting cancel out. This is 4 pi, 4 omega. Sine 4 pi is 0. So that's why we are getting this part as a 0. So you are getting Vm by root 2. Vrms of any sinusoidal wave, either cos, sine, you will get the result Vm by root 2. And what will the average value? Average value of sinusoidal wave will, V average will be 0. That is directly we know, positive, negative. Apply this formula also. 1 by t, 0 to t, sine omega t into dt. So what is the integration of a sine omega t? Minus cos omega t divided by omega into 1 by t, 0 to t, capital T. So 1 by t into, minus we are taking outside, cos omega, and omega is coming outside. Okay, now cos omega t minus cos 0 is how much? 1. Okay, put the value, minus 1 by omega t. Put the value of omega. Omega is 2 pi f. So cos 2 pi f into t, that is f into t will give you 1. F is because f is 1 by t. So t 1 by t and 1 by t will give you 1 only. So cos 2 pi value is how much? Cos 2 pi value is 1. Minus 1 by omega t, 1 minus 1. You are getting 0. So that's why average value by diagram also, and by this way also you can write it down. Prasanna understood? Vaishnavi understood?
Yeah.
Okay. So,
Yes, sir.
okay, clear. If you understood, guys, if you guys understood, then it's very fine. Okay. Okay, guys, write it down. You have a curve like this. Okay, you have a curve like this. So what you will get? Vrms, Vm by root 2. V average 0. This part is clear? Now if you have a diagram like this, in this figure also you will get Vrms is equals to Vm by root 2. But V average will not be 0, V average will be Vm by pi. Okay. What you did means, if you will square this curve, you will get Vm by root 2. Vrms will be Vm by root 2. So Vrms will be Vm by root 2 for this figure also and for this figure also. But V average you will get 0 here, and V average you will get Vm by pi here. Now the time period here was, the time period was 0 to t up to this cycle, But now the time period is means 0 to pi. You are assuming pi here, you are assuming pi by 2 here, and you are assuming pi by 2 here. If you solve this, means you are getting 1 by pi by 2, 0 to pi by 2 time period, Vm sine omega t into dt. Solve this and get the results. What you will get? Vm by pi by 2 sine cos omega t divided by omega 0 to pi by 2. So you will get Vm by pi by 2 into omega, and this will come cos omega, cos pi by 2. Okay, so let me write like this. Let me write like this. Now the time period decrease means you are getting the time period up to this part only. This part. Okay. So this is t by 2 and this is t by 2. Okay. So if you will solve this curve, you are getting Vm minus Vm cos omega t by omega into 1 by t by 2 0 to t by 2. So minus Vm divided by t by 2 into omega cos omega t by 2 into minus cos 0. So I just integrated it and put the value. Omega is what? Omega is 2 pi f. 2 pi f. F can be written as 1 by t. This t will get cancelled out. You are getting minus 2 Vm by pi and omega is 2 pi f. F will get cancelled out. So this is coming cos pi. So cos pi value is minus 1 and cos 0 value is how much? Cos 0 value will be minus 1. I'm solving means wait just a minute. I did some wrong thing here. It's coming wrong. See guys, see, you have a curve like this, you have a sine curve like this. Okay, assume you have a sine curve like this. Okay, now what I am doing, I had made means this positive part I had used a rectifier, and in a rectifier I am getting the positive half cycle only, this positive half cycle only, this positive half cycle only. So if the curve is starting from 0 point and it's going up to pi, this is your 2 pi. So it's starting from 0. So that means it's a sine curve only. Sine omega t curve only. But it's repeating means the cycle become, earlier the cycle was t. Now the cycle become t by 2. Now you have to find the average value. So what was the average value formula? 1 by t 0 to t v of t into dt. Now the cycle became full cycle means see the repetitions became at t by 2 only. So you have to use t by 2. Okay, and 0 to t by 2. Or you can also break the signal. Yeah, you can do like this also, means overall time period is 1 by t, so it became like 1 divided by t by 2, and you are going from 0 to t by 2. Okay, or either you can do, let me show you some pretty good example, means how we are getting this curve. Okay, if we have a sine curve like this, and if we have a sine curve means cosine curve like this. No, we'll not get the result like this. Okay, if we'll do like this, so you have to use the same concept, means like you have to use v average is equal to 1 by t 0 to t v of 2 v of t into dt. So you are using 1 by t by 2 into 0 to t by 2, this curve becoming like this, and you have to put the value of a v of t is vm sine omega t into dt. So what the average value you will get, you will get vm upon you will get 2 vm upon pi, 2 vm by pi. This value you will get. Remember this particular thing. So in a rectifier also, in a full wave rectifier also, what is the average value you are getting? 2 vm by pi, right? 2 vm by pi. Apply the formula and get the result in a full wave rectifier. I hope you guys remember how the full wave rectifier is working. See how rectifier is working. You have particular Vm sine omega t. If you have a DC signal, means if you have a diode, this is half wave rectifier. So this signal it have a positives.
Only the positive side will be.
Only the positive
Positive.
part,
Yeah.
will get, and this negative, positive is there, negative is gone, positive is there. So this is the repetition, means 0 to pi you are getting, 0 to pi, 0 to means फिर 2 pi to 0 to pi, that is 2 pi, that is 3 pi, you are getting like this, right? So this is a half wave rectifier. Okay, so if you will calculate the average value for this, what is the time period? Total time period is 1 by 2 pi. Okay, and what is your cycle, means 0 to 2 pi. 0 to pi you are getting Vm sin omega t. Okay, 0 to pi you are getting the signal, pi to 2 pi you are getting no signal. So 0 to 2 pi you are getting Vm sin omega t. In terms of d omega t I am taking, because I have taken the time period as a 2 pi, so that's why I have taken d omega t, plus pi to 2 pi, the signal will be 0 to d omega t. See, 0. If you will solve this signal, what the value you will get? Vm divided by 2 pi into what is the sin omega t minus cos omega t. No omega will come down because we are doing with respect to d omega t, and we have taken 2 pi only. So put the value 0 to 2 pi. Now what value you will get? Vm by 2 pi into Vm by 2 pi into minus cos 2 pi or cos 0, let me take minus sign outside, cos 2 pi minus cos 0. So guys, this will be plus, because we have break the, so this will be pi, so 0 to pi. So cos pi value is minus 1, cos 0 value is 1. So what you are getting? Vm by 2 pi into minus 2. So what result it is coming? Vm by pi, right? Vm by pi result is coming. Prasanna, you understood this? How we are getting? This is your positive cycle, this part is negative cycle. We are assuming as a omega t, and this is your v of t. The signal is Vm sine omega t. So Vm sine omega t is active from how much, which cycle, 0 to pi, and pi to 2 pi it is off. So that's why 1 by average means average. For finding the average time period, average, we are using the same formula, 1 by t into 0 to t Vm sine omega t into dt. But I have taken with respect to omega t, so that's why I am multiplying omega here, okay, and omega here. So omega means that's why we are taking in terms of a pi. So 0 to pi Vm sine omega t is active, and pi to 2 pi its value is 0. While solving this, minus cos omega t, while substituting this, we are getting Vm by pi. So if the average value of this signal is Vm by pi, if we will add some particular, means the same cycle, if we'll add, then average value will become twice to Vm by pi. Correct? Prasanna, is this clear?
Yeah.
So you just have to, I don't want to, you just have to remember these three things. The average value of this signal, V average, is 0. The RMS value of this signal is Vm by root 2. The average value of this signal is also Vrms is equals to Vm by root 2, and the average value of this signal is 2 Vm by pi. Okay? Okay. Now, if you have this kind of a signal, particularly this kind of a signal, Vrms, this is Vm, Vrms will be Vm only, and V average will be 0 for a square wave signal. If you have a triangular signal like this, okay, if you have a triangular signal, so what is the V average? V average of the triangular signal is Vm by root 3. Write it down. Vrms is Vm by root 3. If you have the triangular signal like this, it's going like this, it's going like this, it's going like this. So Vrms is Vm by root 3, and V average will be how much? That is, what is the area? Area is equals to base into height, half into base into height, half into base into height. So suppose this is your time period. So 1 by 2 base into height, 1 by 2 into time period into height is Vm, and for average you are dividing by time period. So that's why you are getting Vm by 2. Is this clear? Prasanna, is this clear?
Yeah.
So for average means just remember this point. I don't want to mug up all the things. I will take you 5 minutes. For average value of a triangular, you will get Vm by 2. For RMS value of a triangular, you will get Vm by root 3. Okay. Now there is a very much important concept. If you remember this concept na, then everything is done. And for this kind of a signal also, for any kind of a triangular signal, RMS value will be Vm by root 3 and V average will be Vm by 2. Divide the signal like this. What is the area in this signal? Half into base into height. Wait, someone is coming. So you are getting the signal half into base into height. Means now you know, if you understood this concept now, you can solve any kind of a signal for finding. If you remember this triangular concept, square wave concept, and sine wave concept, you can solve any signal. So important formula is what I am telling. Overall vrms is nothing but root under vrms 1 ka square plus vrms 2 square plus vrms 3 square. Okay, so vrms, or we can write your overall vrms is v0 square plus v1 by root 2 square plus v2 by root 3 square. See, the thing is that if you have a signal, means like this, if you have a signal like this, then the signal is again it's repeating like this, you are getting like this, and it's going like this. So see, up to here it is repeating again. Okay, so what is the RMS value of this signal? Vm, all having the same magnitude, Vm. What is the RMS value of this signal? Vm by root 2. And what is the RMS value of a triangular signal? Vm by root 3. So what is the overall RMS? Overall RMS will nothing but Vm square RMS 1 square plus Vm by root 2 whole square plus Vm by root 3 whole square. So like this you have to use and you have to calculate the RMS value. Okay, Prasanna, is this clear? Means you have to remember the RMS value of a square, you have to remember the RMS value of a sine, you have to remember the RMS value of a triangle. And I'd said you how to solve the RMS value also. Means using the concept, using the formula 0 to t root 1 by t root under v square of t into dt. So if you have the signal, means if you got the signal like this, you just use this formula. Overall vrms will be vrms 1 square plus vrms 2 square plus vrms 3 whole square under root. You will get the answer. Okay, and they had asked many times this kind of a question. Okay, this part is clear. So right means it's a very important. What I am saying, it's very important. You just need to write it down again. I am saying you just need to write down twice or three times. The average value of this is 0. The RMS value of this is Vm by root 2. The RMS value of this kind of a signal is also Vm by root 2. The average value of this signal is Vm by 2 Vm by pi. If you are getting the signal like this, so if you are getting the signal like this, what will be the RMS value? RMS value of this signal? Plus 0 into overall time period, that is t. So right now just assume, just take up to this part, means RMS value of this signal, RMS value of this signal, and RMS value of triangular signal. Vrms is Vm by root 3 and V average will be Vm by 2. Okay, so we'll continue tomorrow. Up to here we had clear. So any doubt you are having till now? Is there any doubt? And these things will come repeat in the signal and system. So for now you just remember this formula. Okay, for a sinusoidal wave you are getting this kind of a formula, for a triangular wave you are getting this formula. Okay, these things will be repeat in a signal and system. Okay.
Yeah.
Okay, Prasanna, so we'll continue tomorrow.
Yeah, sure.
Okay.